All right, so today we're going to be talking about Advent of Code, the first day challenge. This year we'll only have 12 different puzzles since the maker of this is quite overwhelmed with the amount of puzzles that need to be made every single year. But each day will still have two different parts. So to unlock the second part, you have to solve the first, and you can read the lore here, which is quite interesting. But let's dive straight into the problem. So we have a safe with a dial that has a single arrow on it, and the numbers are 0 to 99 in this order. So if we draw it out, then it's a dial that you can spin, so to say, and the numbers are from 0 to 99, and the 100th place is also the 0 place because it loops back to 0. So they mention later that if you go to the left, so from 1 to 99 by 2 steps, then it becomes 1, 0, and then 99. If you go to the right, it becomes 99, 100/0, whatever you want to say, and then to the right again to 1. So it's essentially just saying that this actually loops around in a nice way. So what we have is our puzzle input, which we will get later, and it looks like this. It's either L or R. L means left, R means right. So you either go to the right, which means that you add numbers, or go to the left, which means that you subtract numbers. And what we do is that we start the dial pointing at 50, and if we get L68, it means that we started here. So left means that we go this way, so subtract. We subtract 68, and we end up maybe somewhere here. And what we want to know is not just to actually input the password like this, but to actually count how many times the dial will point exactly at 0. So we have to check every time that we've input a new code, is the dial pointing at 0 right now? So if it was at 50 and we go left or right by 50, then it will point at 0. If we were at 2 and we go left by 2, we will point at 0. Same with 98 to the right by 2, it will point at 0. So that is what we want, and apparently that is the password. So if you count how many times it has been at 0, in this example it's 3, and we have to do it with our own puzzle input. So you can click here to get your puzzle input. I have mine already open. So it's here. You can either select all of it, copy, or just download it. And then you can make a text file and just paste it in. Whoops, which I've already done before. Then to actually open the file, you can just do with open the file name and the directory if it's in a different directory. And then we just want to read it as file to give it a name so that we can iterate through it. We go through every single line, and we actually have to strip it since every single new line that we see actually has a new line character that's not visible on our text viewer. But if we actually run it, you will see that line is L5 \n, which is the new line character. So when we strip it, you see it becomes just L5. You won't want to do this for every single line. Then I append the 0th index of line, so just the letter, so either L and R in this case. And then I also append to the amount list from the first index to whatever is the last index. So if you don't put anything here, it will just go until the end, because we don't actually know how long it is. There's even cases where it's 3 digits long. Maybe there's even 4 digits long. Depends on what kind of input you get. So we just want to let it continue until the end, so we get the entire number. And I convert it to integer so that we can use it as a number later on. We know that the starting amount is 50, so I call it current amount 50, and we want to count how many times we arrive at 0. So zeros begins with 0. I made a function, which is a loop number. You don't need to make it, but it essentially just does number mod 100, and it always gives a positive number, even if it's negative 50, then it will become 50, since that's mod 100. Which is nice. And then we just have to iterate through the entire list that we got. We can either iterate through dir list or amount list, doesn't really matter. They're both the same. And then we go and check, okay, is it going towards the right or is it going towards the left? So we'd have to check the direction list, check at what index we're at, and either go left or right. And depending on if we're going left or right, we do something different. So if we're going to the right, what we do is we check the amount list that we have right now. So if it's 20 and we're already at 50 and we're going to the right, it means we're adding. So the local amount will be 70, and I will just add I will just add this to the current amount. So it will become 70, but I also want to store it so that we know how much to loop. So when we go in the loop number 70 mod 100 is still 70. So the current amount is still 70. And this is just to make it loop. So if it ever becomes 150, then we just get return of 50. If it goes left, we do the same thing, but instead of adding it, we subtract it because we're going in the opposite direction. And what I also want to check after every step has gone through, I want to check if the current amount is 0. So if we keep going in all sorts of directions, like from here to here, from here to here, from here to here, we keep going around until at some point it's a 0. We have to check at every point that we actually go somewhere if it is a 0. So that is what we're doing through every single iteration, and then we just print a 0, and it has a time complexity of O of n since there is a single for loop. And my answer is 982, which we can see is correct, and it will be different for you. Another way that we could have done this is actually iterate through every single part, every single number. So if it said plus 20, then we just go 1, 2, 3, 4, 5, etc. And we check at every step if it is a 0 or not. But this is not as efficient, and the time complexity will be a lot worse. But this could be helpful in part 2 as well. So let's go to part 2. Part 2 describes something new. And the new thing is that actually we don't want to now see how many times we are exactly at 0. We want to see how many times we pass through 0. So if we go, for example, this way by 1, 2, 3, 4 steps, then okay, we didn't actually end up at 0, but we passed through 0. So it clicks every single step of the way, and we want to know, did we ever pass through 0? And if so, how many times? And that is the total that we need to keep. So here we have more examples of this. And we see that we rotate through 0 in here several times, and in the end we get this number. But of course our puzzle input is much larger, so we need to do it for that. And we go to the code, we do the same thing. We open it, we have the current position, we have the zeros, we append it to the lists as before so that we have all of them. And what I've done now is still iterate through each and one of them. We have the direction and the distance, but now we have instead of the function that I called loop, I named it hits through 0, and it just counts how many times we actually hit it through 0. And you can implement this one by one, as I've mentioned. So if you go 4 steps to the left, 4 steps to the right, and so on, you could go 1 step, is it 0? No. 1 step, is it 0? No. 1 step, is it 0? No. And so on and so forth, and keep count of how many times it's been at 0. But it would be a lot more complex to run. So it would be n times m, and m is how many steps there actually are. And it would be a lot slower. It would still run on your computer fine, but if the data set were a lot bigger, maybe it wouldn't. So once we do this, what we have to give it is the current position, the distance, and the direction, so that we know which way we're going, and if we ever hit through a 0, and if so, how many times, if the number is bigger than 100, of course. So for example, if we're at step 0 and we have 560, we will hit 0 again 5 times, and then we will end up at 60. So it's a 5 in that case. But the way that we calculate it is we get current position modulus 100 to just normalize it so that this S start is from 0 to 99. And then what we can do is to see where does it first hit the 0 at. So if the direction is R, then we set it as this number. First 0 hit at, we set it as this number, because if, for example, if it's 20, then we are at 20 here. And if we're going to the right, how many steps do we need to go to hit to 100? We need 80, right? So we just need 100 minus 20, which is 80. And otherwise, we don't even have to say if it's L, because that's the only other option. Then we just set it to S, and this is because we're going to the left. So if the number is 98, then we do need to go left 98 times to hit the 0. So it is just what number it is here. And then we have an OR statement here, which means that if this left part evaluates to 0, then it will run, it will set it to 100. So if this is 0, it's the same as a Boolean false. So it will not set it to 0, it will set it to 100 instead. And the only case where this would be 0 is it can't happen if this 100 minus 100 becomes 0, because the current the S is modulus 100, so maximum 99. So it can only be 0 if S is already 0. So if current position is already 0, then it will become 100, and then we will see that we need the distance to be bigger than 100 in that case, because if we are already at 0, how can we hit 0 again? Well, we need to travel all the way around 100 steps. Then we will hit it and we will get 1 step. But if that's not the case, if we don't have enough distance, even if it's with 100 or any steps in between, if it's not enough to actually go around and hit the 0, then it means that we do not get an additional 0. So we will just return 0, and then we calculate again what the current position is in both cases. In one of them we add, and one of them we subtract, sort of like we did before. But in the other case, where it is actually enough, so it does go around once or more times, then what do? So we return 1, because if this statement did not evaluate to true, then it will not go in here and return. So it will continue and return here instead. So it means that it will at least hit 1 time. So we do 1 plus, and then distance minus first 0 hit at. And for example, if we are at 25 and we want to travel, let's say 325 in the positive direction, then we know that we will travel 1, 2, 3 times, and we'll end up at 50. So then 325 minus 25 is 300. Floor division with 100, it's 3. So yeah, we're always 1 hit away. We always get 1 hit, and then we have to see how many more times we're actually looping around it to be able to know how many times total we've hit 0. So once we do that, we calculate it for the new positions. If we go left or right, we print the zeros, and the time complexity is the same. So if we run it, it also runs very fast, 6106, and that is the correct answer from me. So I will be publishing this code to GitHub shortly. I've published last year's code as well, but I will be making a new repository for the 2025 challenges. If anyone wants to join the private leaderboard, I will leave the code in the description. And lastly, I will also leave an invite to the Discord server from my university if anybody would like to join and discuss how to solve problems, and we post the solutions there as well. So thank you for watching, and see you tomorrow.